Hi everyone. Today we are going to discuss on the topic data acquisition and interfacing requirements. First, first of all, we have to understand what is data acquisition in LabVIEW. Generally, the data acquisition is nothing but we have to measure a physical parameters. It may be anything: temperature, pressure, force, level, flow, whatever the physical parameters that we have to measure, we are converting that to a useful format that is read by a computer. So the process that is completing from measurements to send the data to the computer, the whole comprises the concept of data acquisition. When working with data acquisition and interfacing requirements in LabVIEW, the focus is on leveraging the graphical environment provided by LabVIEW to design and implement systems for acquiring, processing, and interfacing data. Here, we are going to discuss some of the key considerations and requirements for data acquisition and interfacing requirements in LabVIEW. First, if you consider the hardware requirements, generally the LabVIEW is a software which is given by the national instruments. So that we have a set of hardwares provided by the national instruments. The first one is DAC device. So the LabVIEW is often used with NI DAC devices like USB, PCI, PXI, or Ethernet and DAC systems. And then the modular instruments. The modular instrument is nothing but whatever the instruments that we need to interface, we can interface with LabVIEW and the DAC devices like oscilloscopes, signal generators, and digital multimeters. The next one is the reconfigurable input output devices. So the reconfigurable input output devices is nothing but the compact trio and compact DACs, so which can be used for more complex and industrial applications. Then NILVIS. The NILVIS is nothing but the Educational Laboratory Virtual Instrument Suite. So these are the hardware requirements which can be used for data acquisition. So other than this, we can use third party hardwares. So the third party hardware is nothing but the external hardwares which used to measure the physical data externally, and we can take that data into a computer. Which the main thing we have to consider in third party hardware is that will be compatible with available drivers and interfaces. The next thing is signal conditioning. Generally there are many areas where we have to concentrate on signal conditioning, like signal level, frequency, analog, digital, whatever the thing. Here we are using NI signal conditioning models, SCXI, or any third party signal conditioning hardware to prepare sensor signals. The next one is software requirements. So generally, if you the LabVIEW completely runs with software, then so the LabVIEW is a developing, and if you consider the LabVIEW developing environment, LabVIEW base, that depending on the complexity or required features, we have to give the LabVIEW access. Then the real-time module for deterministic and time critical applications, or FPGA module for custom hardware logic or reconfigurable IO hardwares. Then the NI DAX needs a driver software, because in LabVIEW we are connecting the external elements, so that has to communicate with the DAC, so it needs a driver. So the NI DAC Max is for interfacing with NI DAC hardware. The instrument drivers like third party instruments like VISA, IVA we can use. Then the toolkits and models. The toolkits and models is mainly used for signal processing. So here we have the signal processing toolkits, which is mainly used for advanced data analysis, because as we have already discussed, the LabVIEW has a more computational power whatever the data it acquires. So in real time, whatever the signal that it acquires, it can perform more computational analysis. So we need signal processing toolkits. Then control and design simulation model. The control and design simulation model is mainly helpful for maintaining control and systems development. where we can employ it in industrial applications and real-time systems. The LabVIEW NXG for next generation graphical programming system design. Everything is readily available as software where we can make use of for data acquisition and interfacings. The next one is communication protocols. So here the main thing we have to consider is what type of communication we need to establish, because we are measuring the physical parameters. That physical parameters, it is basically of a signal. That signal is to be communicated with a system, so we need an communication interface between the physical parameters that we are measuring and the computer where the LabVIEW software is loaded. We can perform different types of communication like wired communication, wireless communication, then protocol, field based communications, everything based on our applications. So if you consider the wired communication, so the external device as well as the computer is connected with a bus signals. So it and it has two types of communication. Either it may be a serial communication or it may be a parallel communication. So some of the protocols that supports the wired communication is GPIB, RS-232, RS-482, then Ethernet. Also we have virtual instrumentation software architecture. Simply we call it as VISA for interfacing with a variety of communication protocols. And if you consider the wireless communications, yeah, because that we cannot go with wired communication all the places. Some of the places we have to transmit the data in a wireless way. There the wireless communication exists. So we are, in that also we have to integrate with Wi-Fi and Bluetooth through appropriate hardware and drivers. We can use NI hardware or third-party modules for wireless communication like Zigbee, LoRa, LoRaWAN, whatever the architectures we are having, we can make use it with LabVIEW. Suppose if you want to go with industry standards, the LabVIEW and as well as the DAC supports the industry standard protocols like Modbus, Profibus, CAN bus, I2C through NI hardware toolkits. Also, it supports OLE for process, that is OPC, for control system integration. So then the next thing is data management. Here in LabVIEW, we are using technical data management stream for efficient data logging and storage. We can use store the data like SQL Server, MySQL, Oracle through database or connectivity toolkits. The data security will be high in LabVIEW. The access control mechanism for LabVIEW application we can restrict. Then the next one is system integration. The system integration in the sense we have to integrate with the software as well as hardware, interfacing with software, web services as well as the ActiveX controls used for integrating with external softwares. It provides much scalability and flexibility, and it will give good maintenance and support wherever we are using. Then it will support interoperability. The main features of the LabVIEW is it supports interoperability because it is compatible with wide range of hardware as well as software. So it will utilizes the open standards and protocols to ensure the interoperability between the existing systems. So now we are going to discuss on the implementation in LabVIEW. First one is the hardware setup. So before performing any measurements, we have to perform the hardware setup. First we have to connect as and configure the DAC NI DAC MX with LabVIEW using measurement and automation explorer, and we have to install necessary drivers for NI DAC MX. The next one is after installing the hardware setups, we have to create a project in LabVIEW. So in creation we have to develop a VA for data acquisition, signal processing and interfacings. We can use express VAs and data assistance, DAC assistance for simplified configuration, because we cannot create all the data acquisition process all the times. We can use express VAs as well as DAC assistants for simplified configurations. Then already existing algorithms for data analysis. Then data acquisition and processing. So after creating the hardware as well as we can create the software program to process the data. Now both the things are ready. We can start acquiring the data using DAC, MXVIs and other instrument drivers, and we can process that in real time using built-in signal processing functions. After performing the signal processing, we have to visualize the data in a pictorial representations like graphs, charts, whatever the mode we need to view, we can view with visualization. And also it has the ability to give intuitive or intuitive with user interfaces, design and intuitive front panels for user interaction, so we can interact, like we have to easily monitor, and it will give more information based on that data that it acquires in the real time. We can use charts, graphs and indicators to visualize the acquired data. The next one is data logging and reporting. If you consider data logging, the data logging, we have to store databases of whatever the data we have acquired, because we can, if you want to view it in later time, we can, we need data logging as well as reports, so that it can be done with the help of TDMS files or databases, and we can generate the reports of the acquired data using report generation toolkits. And after that we have to test and employ whatever the system that we are designed. The test and verification can be done with the help of test application or simulated toolkits. So the test and application is thoroughly done by simulation as well as real hardware. So after completing all the steps, we can deploy the application on the target hardwares like a compact trio or industrial pieces. So what are all the things that we need to do before interfacing with LabVIEW? First, we have to connect the hardware with LabVIEW installed computers. Then we have to create an application where the real-time data can be collected and it performs the process, and it will store in the PC. Then after done these two things, we have to perform data acquisition. We start acquiring the real-time data, and we perform the signal conditioning processing like linearization, amplification, then hysteresis, whatever the signal conditioning options we can do. After that perform the signal conditioning, we have to view the data in real time. For that we keep on using two types of visualization, like the first one is user interactive display, and we have represent with charts, graphs, everything. Then we have to store the data. Why we are storing data? We can view whenever we require. And the last one is testing and deployment. After completing all this, we are now ready to deploy with as a single instrument using compact trio as well as industrial pieces. Thank you. Hope this video gives you more information about data acquisition as well as interfacing requirements for LabVIEW. Thank you.